Hello everyone. In this video, we introduce the basic concepts that you come across in this course, CS 110. The first lecture will be on basics of a computer. Now, nowadays, you find that almost everywhere you go, there will be a mention of a computer system. You go in schools, you find that they are using computers. You go in banks, for example, you find that computers are being used. People are doing their work, maybe their schoolwork, they talk about computers. People who do business, they talk about computer systems. So computers play an integral part, an integral role in our lives today. In everything that we do, or in most of the things that we do, you'll find that we are using computer system. Even in your careers, later on as you start your work, there is a very high chance that you'll be using computers. Some of you are studying to become medical doctors. In the health profession, you'll find that computer systems are being used. Some of you are studying to be mining engineers, metallurgical engineers, environmental engineers, civil engineers. You'll find that in every aspect of your work, wherever you, in every career that you go into, you'll find that computers are being used. And as such, it is important to understand some basic concepts of computers. You'll find also that if you are to check newspapers or other adverts for employment, you'll find that companies who advertise for job positions, they will demand that one should be computer literate. And as such, we want to make sure that before you guys graduate and become engineers, doctors, etc., you guys should know how to use computers. So that is why this course has been included in your program. Now, what is a computer? One definition of a computer that we can give is that a computer is an electronic it's an electronic machine that accepts input, that accepts data from the users, process the data by performing the calculation, by performing calculations and operations to give the desired um, output. So any definition that you can give, if you're asked to define a computer, whatever definition that you give, you find that these four parts should come out, should be clearly included. So regardless of the definition of a computer that you find, wherever you check for the definition, you find that these four features are included. So let's discuss these four features. When we talk about, when we say something is electronic, when you say something is electronic, it means it uses electric energy. For it to function, it uses electric energy. So for something to qualify to be a computer, it should be powered by electricity, electric energy. Now, this electric energy could be in form of a battery. Some of these computing devices that you'll find, they use solar energy, but that solar energy is converted into electric energy before it can be used. Okay, then the second thing, um, for something to qualify to be a computer, it should have a provision to accept inputs from the users. It should have a provision for accepting inputs from the users. Users should be able to give it the data, the inputs that they want worked on. So if there's a machine, but it doesn't have a provision for accepting inputs from the users, then such a machine doesn't qualify to be a computer. Now, when this input has been received, this machine should be able to process the the data, should be able to work on the inputs, the values that have been entered. It should be able to work on them. Now, it can work on them by performing calculations. It can also work on them by performing some other operations. Now, these operations that we are talking about, which make up the processing, could be things like storing the inputs that have been entered. It could include comparing the inputs that have been entered. Okay, it could be adding the inputs that have been entered. It could be subtracting. So when we talk about processing, we're talking about working on the data, manipulating it, working on it one way or the other. Then after working on the data, processing the data, it should give out the desired output. The output should be shown to the users. So in this definition of the computer, what we're saying is for something to qualify to be a computer, it should first of all be electronic. Okay, it should be electronic. Then secondly, there's supposed to be a way for users to be able to give it the data to use. By data, I just mean the inputs, what the user wants worked on. Then there has to be a way of processing the data when it has been entered, and the results from the processing should be given out. So your definition that you are, when you're asked to define what a computer is, those four parts should clearly come out. So that's how we define a computer. Now, given that definition of a computer, it would be nice if you guys can pause for a minute and think whether the following devices qualify to be computers. In addition to this, let me add another one. Think about whether an ATM machine qualifies to be a computer. Ask yourself whether a calculator qualifies to be a computer, a cell phone, whether it qualifies to be a computer, an ATM machine, whether it qualifies to be a computer. So as you're thinking about this, please base it on the definition which we are just from giving. Those four features, see if you can identify them in a calculator, in a cell phone, in an ATM machine, and then decide whether it qualifies to be a computer or not. As we move on, you will forgive me. I think on some screens, you'll be able to, on in this video somewhere, you may see, please move this window away from whatever. Just ignore this this message. All right. We've defined what a computer is. We've given the definition of the computer. So now let's let's move on. Okay. Now, having given the definition of a computer, it's important now to talk about classification of the computer. Classification of the computer. Now, there are a number of ways of classifying computers. Just like when we talk about human beings, there are a number of ways of classifying human beings. When we talk about classification, we're talking about grouping things or putting things in groups. That's the concept of classification. Now, why do we classify things? We classify things so that things which are in the same group are treated the same. Things that are in the same group are treated the same. For example, or maybe before I give the example, we've said we classify things. So that things in the same class or in the same group will have this similar characteristics, the same characteristics, and also they will be treated the same. Now, we can classify human beings, for example, in terms of age. Now, when we classify human beings in terms of age, we'll have groups such as toddlers, we'll have groups such as teenagers, we'll have groups such as, we'll have a group of youths, and we'll have a group of adults. Now, each of these groups will have the same, the members of each group will have the same characteristics. If we talk about teenagers, in terms of their age, they will be the same. They'll be in the same range. And even in most cases, teenagers, you find that they are still in school. Okay? Even the things that they need, they are more or less the same. Okay? So we can classify people in that way. We can also classify people in terms of gender. Now, when we classify people in terms of gender, we'll have males and we'll have females. So we have male and females. We can also classify people according to race. We have Negroids, we have Mongoloids, etc. We can also classify people in terms of height. So there are all these different ways of classifying people. Okay. Similarly, when it comes to computer systems, we also have several ways of classifying these computer systems. Now, one way of classifying these computer systems is by how they handle or how they represent data internally. Okay. Internally, what I mean is inside the computer. How they represent the data inside the computer. That's what we mean internally. If we classify computers in that way, how they handle data handling, we'll have three classes of computers. We'll have digital computers, we have analog computers, and we have hybrid computers. So digital computers, analog computers, and hybrid computers. Okay, hybrid computers. Now, digital computers. Digital computers, they use distinct values to represent data internally. They use distinct values to represent data internally. And all this data are represented using digits 0 and 1. So basically what we mean here is this. In terms of data representation inside the computer, this is how the data will be, sorry about, the length is supposed to be the same, okay? So this is how the data will be represented internally. When it comes to showing the data to the users, you'll be able to see it in terms of words, like we are seeing, numbers, in terms of images, videos, but inside the computer, this is how the data is represented, with maybe a law representing a 0, then this representing a 1, this representing a 0, that representing a 1, and a 1 because here they are 2, then a 0, just like that. Okay, so this is how the data is represented in the digital computers. Most of the computers that we use today are digital computers. The laptops that you see, the desktops that you see at home or in school, those are digital computers. Even your mobile phones, those are digital computers. Analog computers. Analog computers, this is another kind of computer that represents data as a variable across a continuous range. Across a continuous range. Okay, so this is how we can illustrate analog computers. Data is represented across a continuous range. Now here, in digital computers, for example, you can see that the area between here and here, the values are distinct. You can clearly distinguish them. You can clearly tell that this is a 1, this is a 0. But for this one, if you pick this point here and that point here, you may find that maybe the difference could be very minimal, maybe 0.0001, 0.02, something like that. The data is represented across a continuous range. I hope that is clear. The third class of computers that we have is hybrid computers. Now, hybrid computers combines the characteristics of both this computer and that computer. So that is how hybrid computers are. They combine characteristics of both digital computers and analog computers. Okay, so in terms of data handling, these are the ways that you can classify computers. Now let's move on and look at another way of classifying computers. Now, another way of classifying computers is classification by purpose. Now, classification by purpose, if we were to classify computers in this way, we'll have two kinds of computers, namely general purpose computers and special purpose computers. A general purpose computer is one that, given the appropriate application and required time, should be able to perform most common computing tasks. What basically we're trying to say here is this. This is a computer that has been developed to be used in different situations, in different walks of life. You can use the same computer system. Maybe in your engineering work, you use the same computer system. In your business, you use the same computer system. For entertainment, you use the same computer system for a lot of things. So these are computers that have been developed to be used in a variety of to perform a wide variety of operations. I hope that makes sense. The other kind of computer that we have is a special purpose computer. Now, a special purpose computer is one that has been designed for a specific purpose. Okay, it has been designed for a specific purpose. That is, it just has a single purpose, or is just used in one context. To illustrate this, for most of us, when we are growing up, we had the clothes that we had were grouped in they were put in two groups. The two groups that we had were, one, there were those clothes which you can only wear on special occasions. Maybe you are going to church, maybe you are going for some function where you need to look nice. So those clothes were for a specific purpose, special purpose. Then there were other clothes that you can wear on any given day. Okay, you can wear it to go and play. You can wear it wherever you go. On any given day, you can put on that particular cloth, a piece of clothing. So that is general purpose clothing. Special purpose clothes, they were for a specific purpose. And if your parents found you with you wearing that cloth which is supposed to be for a special occasion, um, you may even be disciplined for that. Okay, so even computer systems, we're saying there are some computer systems that have been designed to be used for specific purposes. They are only used for that. For example, when you go to hospitals in intensive care units, there are those computer systems that are connected to the patient. And all that computer system does is to monitor the patient's condition. You cannot use that same computer system, for example, to check your WhatsApp messages. You cannot use that same computer system to perform a calculation or to write an assignment. You cannot do that. It is a dedicated computer, especially developed for that particular job. When you go into a supermarket such as or a chain store such as ShopRite or Pick and Pay, there are those computers that are used at the tills where you go to make your payment. Now, those computer systems, again, you find that they are specially developed just for that task. You won't find that computer being used, for example, in school to give a PowerPoint presentation. That doesn't happen. So this is classification by purpose, whether it's special purpose or it is general purpose computer. These are other examples of special purpose computers we can think of. Now, we can also classify computers by size or by capability. Classification by capability. So this classification, we are saying, this is also classification. It's also called classification classification by capability or capacity. Now, in this kind of classification, we are looking at what the computer system is capable of. Now, when computers are classified in this way, we are looking at how much work is it able to handle. There are some computers that can only handle limited amount of work, even in terms of their speed. They are slower, etc. Then there are also computers that are super fast, that have a higher capacity. So that is the classification. Now, if computers are classified in this way, we'll have 4 classes of computers. The 4 classes that we have will be microcomputers, mini-computers, mainframe computers, supercomputers. Now, this classification, what is happening, we are going from the smallest or the computer with the lowest capabilities. And as we move on, we are going to computers with higher capabilities. So the smallest computer that you find is the microcomputer. Okay, now this computer is the smallest in terms of processing speed. The capacity is small. The storage capacity is also small, and even the speed is the slowest. And usually you find that with these computers, they are only able to handle, or they can only be used by one person at a time. Moving on, the next class of computers is the mini computers. Now, the mini computers, in comparison to the microcomputers, these are larger than microcomputers. They are also faster than microcomputers. In addition, with these, they do support more than one user at a time. Okay, so that is mini computers. In comparison with the microcomputers, these are faster. They have a bigger capacity, storage capacity compared to microcomputers. Then we have the mainframe computers. Mainframe computers, these are larger than the microcomputer. If you compare these to microcomputers, you find that these are larger. They have a higher capacity, a higher speed in comparison to the mainframe computers. Okay. So they have a higher capacity, larger memory in comparison to the mainframe to the mini computers. Then the last class of computers, or maybe before I go to this one, mainframe computers. In banks, you are likely to find a mainframe computer where you find that there could be hundreds of users connecting to the same mainframe computer, which is being used. The same mainframe computer that is being used. So there are terminals connecting to this single machine, and it's able to process all the instructions at this instructions from hundreds of users at the same time. The last type of computer in this class, in this way of classifying them, is the supercomputer. Now, with the supercomputer, these are the fastest computers. They have they're able to handle a lot of users at the same time, thousands or maybe even millions of users at the same time. Imagine the kind of computers that are used, for example, at Facebook or let's say Google. You may find that at a particular time, there could be thousands of users accessing the same computer. So with this, it requires a larger capacity for them to be able to handle that the traffic. Okay, so that's classification in terms of computers. Now, just in terms of capability. So just to summarize, we are saying in this way of classifying computers, we are moving from the slowest computer. As you go down here, computers are becoming slower, they are becoming cheaper, they are becoming simpler, and they are becoming smaller. Smaller in terms of capacity, in terms of processing speed, capacity. Then as you go up, they're becoming faster, more expensive, complex, and larger. All right. Okay, so the last thing I'll talk about in this video is to talk about characteristics that have made computers attractive. Remember, I started this video by talking about saying wherever you go, you are likely to find the computer being used. But what is it about this computer that has made it so attractive? The characteristics that have made computers attractive are: one, their speed; two, their accuracy; three, diligence, storage capability; and they are versatile. So these characteristics are key. They are key characteristics of the computer, which has made them very attractive. Accuracy. Oh, let me start with speed. Computers are able to process data at a very fast speed. In comparison to the human being, computers can handle a lot of instructions at the same time. Millions of instructions per second, and that has made computers attractive. We want to do a lot of things as human beings. Now, if let's say I was to employ someone to say, do this for me, it may take them years just to finish something. But with computer systems, within a very short time, it can be done. An example that I can give you, when you guys were submitting your application to come to CBU, you submitted your application online using a computer system. And After submitting your application, it was received, and within a very short time, we were able to classify or to determine who qualifies and who doesn't. All that we needed to do, for example, was to say for non-quota, BSc non-quota, the cutoff point maybe for boys will be 8, for girls it will be maybe 9, and then we say filter. And just by doing that, within a few seconds, we have the list of people who qualify. Before we started using computer systems to classify people here at CBU, you'll find that it used to take quite a while. A committee will be called of people, let's say in a particular school, and maybe they can take the whole week just trying to sort out who qualifies, who doesn't, who qualifies, who doesn't. And after sorting them, they now needed to compile a list. So that used to take quite a while. But with computer systems, within a few seconds, even a few minutes, it's done. So that is attractive. Another reason why computers are attractive today, their accuracy. Computers have a higher degree of accuracy. Now, by accuracy, let's say when you are doing your grade 12 mathematics, when a question is given, you'll be given an instruction, for example, to say, give your answer correct to 2 decimal places or correct to 3 decimal places. Why the examiners were doing that was because they knew that if you were asked to give your answer to a higher degree of accuracy, maybe correct to 10 decimal places, chances of making mistakes was very high. So they limited the degree of accuracy. But with computer systems, they can give results to a higher degree of accuracy. So they've become attractive. In manufacturing, for example, where we want things to be almost the same, more or less the same, computers are attractive in computer-aided manufacturing. All right. Diligence. Diligence means computers are able to work for a long period of time without getting tired. Most of you, I'm assuming you have mobile phones, and as long as your phone is charged, you won't find a single time where your phone will complain to say, no, I think I need to rest a while for me to continue functioning. Your phone will be working just fine as long as it has power, it will continue working. It will at no point get tired. So that is diligence. Storage capability. Computers are able to store a lot of large volumes of data in a very small physical space. In a very small physical space, we can store a lot of data. So that is another reason why computers have become attractive. All right. The last characteristic is that computer systems are versatile in nature. Now, what does this mean? It means we are able to perform different tasks with the same ease, same amount of effort. There are different types of tasks that we have. Some tasks, for example, require calculations, others don't. But with computer systems, what you find is they are able to perform these different tasks at the same rate. They're able to perform tasks at the same rate, and because of that, they are attractive. So these are some of the reasons why computer systems are very attractive. So I'll stop here in this video. In the next video, we'll start talking about computer generation. So thank you very much for watching. I'll see you in the next video.